And that's what we're going to be doing today, is graphing sine and cosine. And to do that, just like any other function, you can eventually make yourself just an XY chart. And what I gave you as a DOM was an example of how you could just plug values into the function and get their Y values. So, what is f of pi, someone? -1. Very good. What about 3 pi? -1. Now, well, we'll talk about this in a second. What's 3 pi over 2? And 7 pi over 2? Would you agree that after every 2 pi, that graph's going to get really redundant because it's just the same thing again and again and again? That is why if you graph cosine of x on your calculator, which I will do now, go. If you graph sine of x on your calculator, it doesn't even, well, I guess you need to be in radian mode, which I am. Y equals cosine x graph. That's why it's really repetitive. Really repetitive. Now, on your unit circle, what's the biggest number that cosine can be? Yeah, 1 is the highest number that cosine can equal. That's why on the graph it never goes higher than 1, and it never goes lower than -1. Cosine and sine are the most redundant and repetitive functions in the world, but we're going to learn how to graph them today with accuracy. I used to make people do this without a calculator, and here's the thing, you can use the calculator on your test, but on the test I'm going to be asking you things like, what is the phase shift of that function? And that you can't get, so it's still important for you to take in what I'm going to be showing you today. Okay, first things first. We're going to graph one of them together. Someone have the unit circle out, and I'm going to ask you about a whole bunch of values. Oh, Sam, are you volunteering? Attaboy. We're going to go cosine first. Blue is going to be cosine. Go! Sam, what is cosine of 0? 1. Very good. Now, you may notice that my x-axis looks different than most axes. I didn't use numbers. Because I made it myself, I went ahead and put what I know to be the major numbers for cosine. Pi over 2, pi over 4 would be in the middle, etc. When you graph on your calculator, it's going to do 1, 2, 3, 4, 5. So you'll just have to kind of know this is 1.57, 3.14, etc. You know. But anyway, Sam, what is cosine of pi over 2? The top. 0. What is cosine of pi? What is cosine of 3 pi? 0. Cosine of 2 pi? 1. Now I'm going to ask you something a little more different. What about negative pi over 2? What would cosine of negative pi over 2 be? 0. Okay. Now if I connected my dots, just like on any other function, oh man, this is going to be ugly. Here I go. I'm going to try. You connect your dots. Etc. Now, you may hopefully recognize, wouldn't you agree that starting right here, it's just going to start repeating what we've already done? It's going to go up, and then down, and then up, etc. See that? How long does it take to get from here to here on x? I mean, what is this distance? What is 3 pi over 2, negative pi over 2? How far is that? 2 pi. 1 revolution around the unit circle. The period, very nice, by the way, Nacho. I really like that. The period of sine and cosine is 2 pi. The period is how long it takes for it to start repeating itself. A periodic function is a redundant function, something that just does the exact same thing over and over and over again with no variation. A periodic function is a redundant function, and a period of a periodic function is how long it takes for it to go 1 revolution before it starts repeating. So for sine and cosine, that's going to naturally be 2 pi. Now we're going to go over sine. Let's go with somebody else's time. Lakeepa, you got your unit circle in front of you? Yes. What's sine of 0? Sine of pi over 2. Sine of pi. 3 pi over 2. And 2 pi. Very good. Connect the dots. This looks familiar, except for the color. What's an observation someone can make about this if I had drawn it a tad more accurately? It's the same exact function, except shifted, right? Sine and cosine are really the same thing. It's just they're not in the same, they're all like one quadrant off from one another. Sine and cosine are the same function. The only difference is, I always think of my functions as starting at 0. It's just a natural place to start. Sine starts at the origin, 0, 0, and cosine starts at 0, 1, which comes straight from unit circle. Sine of 0 is 0, cosine of 0 is 1. Those are the base functions. Those are the parent functions. I know you've heard me say that 100 times here. The parent functions of sine and cosine look just like that. Now today we're going to be stretching them, flipping them, moving them all over the place. But it's going to be just as simple as these things that we do on the walls all over the place. I'm going to be showing you how we're going to shift them vertically and horizontally, how we're going to stretch them and compress them, and all that stuff. But here are the parent functions, sine and cosine. Repeat what? No. Well, I mean, it's good to know their general shape, but you don't have to have it written down. Okay? All right. Now, here we go. First thing we're going to talk about is the amplitude and period. You want to write down this. Just the equation part for this function, and you need to write down what the amplitude and period are. I only showed you what sine of x was, but now we're going to look at things like 3 sine of 4x. The amplitude is how high and how low it's going to go. You know how, like, people have amps, the speakers, and if you're ever watching, like, one of those digital sound things, like when there's loud boom, like, the line goes everywhere, like, it's crazy. That's the same thing. Amplitude is just how high and how low your function is going to stretch. Now, the natural amplitude for sine and cosine is just 1, because it goes from 1 to -1, right? But whatever this number is out here, way out in the front being multiplied by the function, that is going to be your amplitude. The only reason it has absolute values is there's kind of no point to have a negative amplitude because it goes both ways. So if it was 4 sine of x, your amplitude would be 4. If it was -4 sine of x, your amplitude would still be 4. You don't give a negative amplitude. That's the only reason it has to be written like that. Period. Now, what did we just graph? We graphed sine of x, right? So if it was just sine of x, you could think of b as just 1, which is why the period of a standard sine function, 2 pi over 1, is just 2 pi. What if it was like sine of 2x? What if it was sine of 2x we were graphing? Here's the way I always thought it was helpful to look at this. The number being multiplied inside your parent, think of that as like the speed. We're now going to graph sine of x twice as fast. So instead of taking 2 pi, how long is it going to take? Just 1 pi. Think of this as your speed. To find your period, you just take 2 pi divided by whatever your speed is. So a fraction is going to make it bigger, like 1/3 x is going to make your period longer because you're slowing down. Let's look at one. All right. All we have to do on these is state the amplitude. What is the amplitude of number 1? What are these? Nate. 4, thank you. Ashton, what about number 3? 1/3. And Sarah, what about number 5? 3. We don't worry about negatives on amplitude. So it would just be 4, 1/3, and 3. It's going to tell you to graph a whole lot today. You don't have to graph all of them. I'll show you the ones you have to graph. So amplitude, just the number in front. Question? Good. It also wants the period, but let's just knock out all of our amplitudes real quick. Well, what's amplitude of number 7? Yeah, just 1. So here's my number. Chris, what about number 9? 3. Very good. Katie, what about number 11? 4. Bridget Pass, what about number 13? 3. There you go. And Justin, what about number 15? Very good. Questions about where we're getting the amplitudes. They're the second easiest thing we're going to learn today. Believe it or not, there is something easier. Chris, you subscribe and anything away, please. Nate, head up, big guy. All right. Period. Period is 2 pi over the number being multiplied by x. So, what will the period be on number 7? Who wants to tell me? Marco. Well, that's the number you're dividing by. What will your actual period be? Pi. Very good. It'll be pi. What will the period be on number 9? Leslie, how am I going to set that up? Very good. 2 pi divided by 1/2, which is the same as 2 pi times 2 over 1, which is 4 pi. Very good. 4 pi is your period. What about number 11? Ryan. Very good. 2 pi divided by pi will just give you a period of 2. What about number 13? Just come with that. Sam, what's the period of number 13 going to be? What am I dividing by? Two pi. What's 2 pi divided by 2 pi? There you go. Period is 1. Jalen, how am I going to set up my period for number 15? 2 pi over 2/3, which is the same as 2 pi times 3 over 2, which would be what? 3 pi? Period is 3 pi. Divide by the coefficient with your x. Bang. Period. Questions? In a second, we're going to put these all together and graph them all at once. I don't think it's really fun to graph every one of them. Okay, if there's no questions on those, let's move on to the shifts. The phase shift. This is what you need to write down. If this is your function, this is how you find the phase shift. C over B. C over B. Now you may notice all of these say sine because for some stupid reason the book decided to break up sine and cosine, but they're the same. Sine and cosine, everything's the same in all these. You still find the amplitude, the period, the phase shift, all the same way. Nothing changes. So even though these all say sine, please note that both sine and cosine. Now also notice, see how it says Bx minus C? That means, remember how like when we did synthetic division, if it was x minus 4, you just took the 4? Same thing. If it's minus, you just take C as it is. But if it's plus C, then it'll be like the negative of that number. So that'll be something we'll have to keep in mind as we're doing our examples. Okay, we won't, well, yeah, we're going to go through everything. First thing we're going to do is knock out all of our amplitudes. So, rapid fire. Marco, what's the amplitude on 17? Very good. Sarah, what would the amplitude be on 19? Very good. Bridget Stahl, what would the amplitude be on 21? Very good. Blake, what about 23? Amplitude. I think it's actually 1/2. Is it a little too small for back there? I'll make it bigger. I apologize. Jocelyn, what about 25? Amplitude. Very good. Katie Beth, what about 27? And Brianna, what about 29? Very good. Those are our amplitudes. Now, let's knock out our periods before we even talk about phase shift. Now remember, the plus and minus doesn't matter at all to the period. The only thing you care about is the number being multiplied by the x for your period. That is it. So, Amanda, what's going to be the period of 17? Well, that's the number right here, right? So 2 pi divided by that. 2 pi divided by 1, 2 pi. Very good. Zach, 2 pi divided by what? Which would give us pi. Very good. Holly, 2 pi divided by what? Therefore giving us a period of? Very good. Diana, 2 pi divided by what? What's the number being multiplied by x? 1. Giving us a period of? Very good. Latifa, 2 pi divided by what? Giving us a period of? Awesome. Kevin, 2 pi divided by what? Giving us a period of? You guys are awesome. And Leslie, 2 pi divided by what? 2 pi, giving us a period of? Very good. Those two things are down for every problem. Now, let's list the phase shifts. I'll show you one of them, or 2 or 3 of them, and then we'll talk about the others. Phase shift is the opposite of this number divided by the b value that you just used to find your period. So on 17, the opposite of this number, so pi divided by, what number is being multiplied by x? And that is your phase shift, which is the exact same as a horizontal shift back in the day when we did these, but we'll look at what it means in a second. This is how much we're actually shifting the function left and right. Phase shift. So that one would be pi over 1, giving us a phase shift of positive pi. Well, you remember how when we did horizontal shifts, if inside the parent function was like x minus 2 squared, it actually moved it right? Same thing. Because that's what this is. It's a horizontal shift. That's a good question. All right. Let's skip down to a harder one. 25. Negative c, so negative pi over 2, over b, negative pi over 2 over 2. Justin, what's negative pi over 2 over 2? Since we talked about this yesterday. Remember we said when there's a fraction on top of another denominator, you just multiply them. There you go. Negative pi over 4 would be the phase shift on 25. 27 would have a phase shift of negative c over b, and there's nothing you can do there. That's your phase shift, negative 2 over pi. That's how you find them. Believe it or not, we're almost done with this whole lesson. There's only one more thing after this, and it's the easiest thing of the day. So, let's look at an example we haven't done yet, and somebody tell me how to set up for the phase shift. Sarah, how am I going to set up my phase shift for number 21? Well, not the x, you just take the number. Pi over 2, there's your phase shift. Pi over 2. Beautiful. Marco, what about 29? Yes. Yes. Do I need to make this bigger? No. Who wants to help him out? Jalen? How do I set up the phase shift in 29? Negative 4 pi, you take the opposite, over 2 pi. Oh, well then you were probably right. Okay, would you say negative 2 over pi? Well then you were right. But 29, negative 4 pi over 2 pi, which reduces to? Negative 2 would be your phase shift. We are going to put all this together in just a second when we start graphing. All right. Now, click a little further. Vertical cosine. Vertical shift is the easiest thing. Oh, just kidding. Where's vertical shift? I apparently left it off. Vertical shift is the easiest thing in the entire world, and it's the exact same as it's been since the very first section we did. Without even telling you where you're going to find vertical shift, who thinks they can look at this and tell me what the vertical shift is on number 53? It's 2. What about 55? Down 3. 57. Up 1. 59. Now, darn them, they didn't put any phase shifts and vertical shifts in the same problem, so we're going to make one. You may be saying, how can you tell the difference between a phase and a vertical? Because all the phase shifts have parentheses. All the verticals will be separate. So, darn them for not giving us one of both. This is what one would look like that had both. Phase shift would be what was inside. Vertical shift is what is on the outside. Now what we're going to do now is we're going to put this all together and we're going to graph. In fact, let's just do 45 the way I've redone it. Now, yeah. Let's do 45 the way we've rewritten it. Actually, that takes us to this. Okay, 1 second. Graph paper. Now, it says on all of these just to graph one period, which means once you've gotten back to where you're going to stop, you're done. So that's all we're going to do, assuming this thing ever opens. You can do it. I believe in you. Okay. All right. Paste. We're going to graph this guy right here. Okay? So, what we need to know going into it, we need to know, first off, what's my base function? On this one it is cosine. You're going to need to know your amplitude, your period, your phase shift, and your vertical shift. Now, not a single problem you have today requires all four, which is a darn shame, because your test will. So, by golly, every example we do is going to require all four. Okay, first things first. What's my amplitude? Jordan. 3. Very good. What is my vertical shift? Let's just knock the easiest stuff out first. Ashton, what's my vertical shift? Very good. Ryan, how am I going to find my period? That's phase shift. But we'll go ahead and do that. Negative C over B. Was that pi over 2? Pi over 2. And period. How am I going to find that? Justin. Which is, B is what? In this problem it would be, so 2 pi over 2 gives me, very good. Now here is how you start solving these. Here's how you graph them. Here's how you graph one period. Remember how I said I always like to start on 0? Well, if we were to start on 0, at x equals 0, what did cosine start at? At 0, what was cosine equal to? 1. So naturally, we'd start here normally. But what's my amplitude now? 3. Now, before we go any further, so this would be where we're going to start. However, if we had no vertical shift, an amplitude of 3 means we're going to go as high as 3 and as low as what? Negative 3. Very good. That's what we would be doing. However, because we're shifting up 2, we're no longer going to be at 3 and negative 3. We're going to be at 5 and negative 1. Now, you don't have to mark that, but it's just handy to know. So, our amplitude is 3, and our vertical shift takes us up yet 2 more. So, we're going to start right here at 0, 5. Believe it or not, that's the hardest part of the whole thing, is putting your first point on. After that, it's mostly a cakewalk. 0, 5. Now, let's go back to the parent function so we know what to expect here. We are looking at, boy, I really went a long way, didn't I? You know what? I don't feel like doing this 100 times. I'm just going to move this next to the graph. Okay. We are looking at this. We are looking to graph this period right here, which is going to make one big U. See that? And here's the point we're starting with. So we were amplituded up to 3, and then shifted 2 more up to 5. So that's why we're there. Here's how simple it is to graph these once you have that. Now, because we're graphing them by hand, you can make your axis whatever you want. I'm not just going to go to making pi right here, because then that's a whole lot of wasted space. I'm going to make my pi way out here, just because I can. 1, 2, 3, 4, 5, 6, 7, 8. We're going to call this pi on the x-axis. What's my period? Pi. Your second step to graphing all these every time should be to go the length of your period away from your first spot and make that spot again. Because what is a period? What's a period? A period, by definition, is how long it takes it to start repeating itself, right? So after pi, we're going to be right back to where we started. That's the whole benefit of finding our period. After you've gone a full period, you'll be right back where you started. So that'll be the next step all the time. You're going to go one period away, put your next dot. Okay? Now, check this out. You could punch in a whole bunch of values, but we already know what this thing looks like. It's not changing from the parent. What was happening? Think it back to our original without me bringing it up. We start and we finish here. What was happening right in the middle of these 2 points? It was having its minimum, right? So that's what we're going to do. What? We said it's going from 5 to what? -1. So right in between here, at pi over 2, it's going to have a minimum. Oh, touche. What the heck are you doing? You didn't do my phase shift. Why didn't you say something sooner? Not a big deal. Everything's going to be the same. We just have to shift it. Actually, I'm glad you mentioned it like that. That's what the whole thing would be. However, as Ryan pointed out, we didn't do our stupid phase shift. Nothing's changing. We just have to take everything we've done, shift it right, pi over 2. So that's all we're going to do. I'm not going to pretend I did that on purpose, but it's going to work out well. So we just got to shift everything right, pi over 2 units. That's my actual point, actual point, actual point. And nothing is changing. We're just going to use the red dot. Okay. Now from here, I'm not going to be picky. I only want you to sketch these things. That is one period of the cosine function. Done. And there's a way for you to check on your calculator and see just how accurate you were. Hopefully you all have a graphing calculator in front of you. We're going to graph this thing together. Okay. We're going to punch in the function exactly as it is. Make sure you're in radian mode, which we are. Y equals 3 cosine 2x minus pi, close parentheses, plus 2. Do not hit enter yet. Did I mess something up? Okay, now, here's the thing. If you just hit enter, it's going to be a little bitty squiggly line. You're going to be like, well, how does that help me? Next thing you need to click is window. Let's only look at what we want to look at. It's saying, where do you want to look at on the x-axis? Well, what did we do? We went from pi over 2 to what? What is this value? Well, we were at pi, and we shifted right, pi over 2 units. What's pi plus pi over 2? 3 pi over 2. So we're going from pi over 2 to 3 pi over 2. Pi over 2, window, to 3 pi over 2. Okay? Now it's going to naturally convert them to decimal for you. Now, always go by ones. Just 1 for your scale. How low did we go in terms of y? -1. And how high did we go? To 5. So we're going to go from -1 to 5. -1 to 5. And before I hit enter and show you the magical bliss of this, let me make sure that everyone has what they need from that screen. Whoa, one of these. Yes. Okay. Rather than look at a huge cosine function when we are only interested in the period that we graph, I'm taking, basically, if I said what's the domain and range of just this red portion that I've graphed, that's what we plugged in. We plugged in as far left as it goes, as far right as it goes, into the x, and we plugged in how low it goes and how high it goes into the y. What? For x? X max? 3 pi over 2. Because that's where we stopped right now. That's where we stopped. Is there another question about our window? Hit graph and you should be looking at a U. Oh, wow. You should be looking at a U. Hot diggity dang, we did it right. That looks exactly like what we put. Change it to radian mode. Radian mode. Need to be in radian mode. How did you get the on the y? How did you get the pi? Good question. What was our amplitude? with the 3, right? So that means we're going from 3 to negative 3, right? Yes. But we were shifted up with a vertical shift of 2. So you have to add 2 to both of those, and you have 5 and negative 1. Who am I helping?
Oh, no, it doesn't look like it's taking the vertical. She didn't say anything.
All of that. But if you're coming on to say that, maybe start okay, does anybody else have a calculator issue? Calculator issue? No? All right. Okay, what's your question? Yes. The vertical shift? Yes. Okay. Sine and cosine normally go from 1 to negative 1, right? But then the amplitude stretched us to 3 and negative 3, right? Well, our vertical shift was up 2. You remember how we were graphing 1 over x and 1 over x squared? When we had a shift, we just basically moved our asymptotes. Same kind of thing. It goes from 3 to negative 3, but when you shift it up 2, you have to shift both, so now it's 5 and negative 1. Because you just add 2 to those, all right? Let's look at another one. Let's look at a sine one this time. Oh, yes. That's what Ryan brought to my attention. I forgot to do the phase shift initially. That's where the green dot came from, right? But notice, the green dots are the same as the red ones, just shifted over. Because our phase shift was positive pi over 2, so we shifted right pi over 2 units on all 3 of them. It'll probably make more sense when we do another one. Let's do one that's a sine function. Sine function, where are you? Let's do, 25. 25. Oh, done. Is everybody done with that function I put up there? It takes forever for you to make this graph paper appear again, so I'm just going to use the same graph and erase it. Did anybody need anything from that graph before I erase it? Anybody? No? Okay. So, paste. Actually, let's go ahead and get rid of all this. Erase, erase. Oh no! What's happened? Delete. I don't know what just happened. That was weird. I thought I like deleted my whole computer. Okay. So here we go. Now let's just tack a vertical shift on there. Go nuts. Jordan, what's a good vertical shift? Make it a minus. Minus what? Ooh, going with pi. Just a number would be nicer. Give me minus some number. There. I like it. Keep it simple, stupid. That's fine. Minus 1 is fine. Minus 1. Like, man, you are cruel. Okay, minus 1. Here we go. We still have to know our amplitude, phase shift, period, and vertical shift. Amplitude, period, phase shift, and vertical shift. Okay. First off, what's the amplitude? Good. What's the vertical shift? Very good. What's the period? Who can tell me what the... Aw, hold on, I'm changing this. This one's too easy. 1/2 x. Okay, that's prettier. Now, what is going to be the period? Who can tell me how to find the period, and then you can tell me what it is? Latifa. Which would equal? That's right, so 4 pi. You're exactly right. 2 pi divided by our b value. Last but not least, bless you, the phase shift. C, negative c over b, which is negative pi over 2 times 2 over 1. Cancel, cancel. Was that left pi? Minus pi? Okay, here we go. Erase, 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 erase. Before we go any further, raise your hand if you have a question about where on earth we came up with any of this. Phase shift. The formula for phase shift is negative c over b. So negative c over b, which was 1/2. And you had to flip and multiply, which is negative pi over 2 times 2 over 1, which is negative 2 pi over 2, which reduced to negative pi. Okay? Okay, let's do it. Yeah. Okay. All right. Now, where does sine start? It starts at the origin. Right. It starts at the origin. Now, what's my... Normally, I'd go from 1 to negative 1. What's my new max and min going to be after the amplitude? 2 and negative 2. But my vertical shift is taking us down 1. So instead of 2 and negative 2, it is 1 and negative 3. Now that won't really affect me on my first point since we start at the origin, but that'll be good to know in a second. So we're starting at 0, 0. And since you can't stretch 0, really the only thing you have to worry about is your vertical shift. So it's down 1, right? So instead of starting at the origin, we're going to go down to 1. That's where your first point's going to be. Because the vertical shift is shifting you down 1. The reason, again, that amplitude didn't affect where we started is because when you multiply an amplitude times 0, it's still 0. So that's why the amplitude didn't matter. Now, let's do our phase shift first, so we don't run into last time's problems. My phase shift is going where? Left 1 pi, right? Well, you're making this. So make pi however many units away you want. I'm going to go 4. We're going to call that pi. Negative pi. We're going left pi units for our phase shift. We've shifted our function left pi units. That's our first point. That's the point. Let me go back to sine. Oh, wrong direction. Ah, what the heck? Where did I put this stupid thing? Hold on. There it is. Alright, let's go back to our original sine. Originally, sine started at the origin, right? It had a vertical shift of down 1, and we had a phase shift of left 5, which is why our new initial point is right here. All we did was shift our starting point with our vertical and phase shift. Alright? That's why it's here. Questions on that before we go any further? Okay, what's my period? 4 pi, which means I go 4 pi units away and make the same exact spot. So what's 4 pi away from 1 pi? 3 pi, that's right. This one's going to take forever to do 1 revolution, but that's okay. All the way out here at 3 pi, you're going to make another dot. Bang. That's how long it's going to take you to do 1 period. Now, sine, even though they're the same function, because if you're like me, you like to start at 0 because it's just the easiest point, even though they're the same function, 1 period of sine looks a little different. It looks like that, like a heart monitor blip. Okay? So, that's what we're expecting to see, something like that. However, since we're here, what happens directly in the middle of the beginning and end of our period for a sine function? You have another 0, don't you? Right in the middle, don't you cross again for a sine function? So we're going to go to our graph. Bang. Okay? What happens in between these two zeros on a sine function? You have a max, and then you have a min. However, who remembers, what does a negative in front of a function do to a function? It flips it. So instead of being up and then down, what do you think it's going to do? It's going to go down then up. So this is why we talked about our max and min earlier. Didn't we say we were going to go, let's see, 1 to 3, right? Wow. My scale is really off. So let's call it this. Let's go like 3 units for 1. That'll be 1, negative 1, negative 2, negative 3. That way it fits the rest of the scale of the picture. Although it's still not perfect. But whatever. Okay, so instead of going up and then down, because it's negative, you're going to go down first. So you're going to go down to your minimum, which we discussed to be negative 3. I think I counted too many, but whatever. Oh, hold on. I can't do this. My original points were using the y-axis as just 1 unit, so I have to stay with that. So 1, negative 1, negative 2. We didn't mess anything up, but my original points were using the idea that that was negative 1 with my vertical shift. So I have to be consistent with that. Okay, so right in between those two is going to be what? 0? And you're going to go down to your minimum. I don't know why I switched colors. Right there, at 3. And what's going to happen between our next two zeros? Instead of a minimum, you're going to have a what? Maximum. Darn it, I'm overlapping it right there. Right there. Connect your dots. And there is 1 period of that sine function. We're going to do several examples. Let's see if we're right. Jog on over to your calculator. Y equals negative 2 sine 1/2 x, I'm just going to use a decimal, plus pi over 2. Close, minus 1. What do I need to do before I hit enter? Window. Who said that? Bridget, can you help me with my window? Hey, we'll start with that. The y minimum is negative 3. What's the y maximum? How high did we go? It's right here. Just 1. Yep. So negative 3 to 1. What about my x-axis? How far left and right did we go? There you go. Negative pi to 3 pi. And I think we're ready to graph. Come on. Yay! Now it may look a tad different in the way it's skewed just because they use a different scale than we do. But you can see, started here, went down, went up, and there. Yay. So we were right. What do you think is the hardest part about this? Well, the graphing, yes. But, like, what part? Ask yourself this: if you started at the right spot, is it the starting point? Is that the hardest part, or is it the vertical shift, or is it the phase shift? What's the hardest part? The period of phase shift. Okay. Let's emphasize those on the next example then. Do you want to do a sine or a cosine in the next example? Cosine. Let's just go crazy and make it up ourselves. Can I erase this? Anybody writing anything off of this? Alright. You guys are going to make this one yourself. You're going to tell me we're going to go nuts. No. I guess if you like to start at 0 like I do, cosine will make a natural U when you graph it, and sine will actually look like a... There technically isn't a difference, but by looking at that one thing, then they look different for that one degree. Cosine starts at the maximum unless it's negative, whereas sine starts at the 0. So little things to know when you're graphing. Okay, here we go. Who wants to be cruel? Blake, you're looking cruel today. Go. Give me a cos. Okay, we said we're going to do cosine. What should my leading coefficient be, Blake? -4. Very good idea. Let's make it cruel. All right, Blake. What should be multiplied by my x? Ooh, throw a pi in there. I like it. 1/2 pi x. Ooh, I like it. Now, what's going to be my plus or minus? Can I just say you probably want to throw a pi in there as well? Because otherwise you're going to have something divided by pi when you do our phase shift, and that's just going to be ugly. Ooh. Oh, look at the man go. 7 pi over 4, that's more mean than I would have even been. But that's cool. Minus 7 pi over 4. Man, I fear what you're going to tell me for a vertical shift. You're going to throw pi in there again, aren't you? Don't you dare. Just give me a number. I don't want it to. That would be just mean. Plus, minus. Plus 2? I can't do 8. That's too high. But I like where your head's at, but that's literally too high. Plus 3? Okay. Here we go. We still need all the same stuff we ever needed. Amplitude. Let's see. This has an upshift. So let me come down here. Amplitude, period, phase shift, and vertical shift. I should make you give them all to me, but I won't. Sam, what's my amplitude? +4, that's right. Jordan, what's my vertical shift? Up 3. Zach, how am I going to find my period? Again, you're thinking phase shift. Wait, did you just give me the whole thing, or did you give me how to do it? Oh, it's 2 pi divided by your b values. So 2 pi divided by 1/2 pi. The pi's are going to cancel. Yay. That's going to make things kind of nice. What's 2 divided by 1/2? 4. So our period is just 4 units. That's good. We can just use nice integers. Thanks, Blake. Phase shift. -c. So negative 7 pi over 4. Divided by b. Oh man, you're a cruel man. 2 fractions stacked. Alright, no huge thing. So we have to flip and multiply. 7 pi over 4 times 2 pi over 1. What is that, 14 over 4? The pi's are going to not cancel. Darn. Yeah, they will. The 2 pi will be down here now. Hold on a second. Yep. So it'll be 14 over 4? 7 over 2. Yep. Alright. Before we go any further, what questions are there about how we got those? -c over b. So +7/4 divided by 1/2. The pi, 1/2 pi. The pi's canceled, and you had -7/4 divided by 1/2. -7/4 divided by 1/2 is the same as, +7/4, which is the same as times 2 over 1, right? Which gave you 14 over 4, which reduced to 7/2. Well, we divided, by doing -c over b, we ended up with pi over pi. So I went ahead and canceled them before they became a headache. Because you took 7 pi over 4 and divided it by 1/2 pi. So you won't have one like that today, because that can get a little confusing when you flip it. Where does it go? But we're doing a hard example, so there you go. Other questions before we start graphing? Okay. All right. Now, a cosine function. A cosine function, does it start at 0 or at the maximum? It starts at the max. However, what's happening to ours? It's yes, except see how it's. So instead of starting at the max, where do you think we're going to start? At the min. It's going to be like an invert. It's going to be an n instead of a u. So normally we would start, a negative cosine would be here. However, my amplitude is going to stretch us instead of 1 to -1, 4 to -4. But if we were at 4 and -4, then what's my vertical shift? So is that 1 to 7? -1 to 7? So -1 to 7. And we know we're starting at our minimum, so we're going to put our first point at -1. And there's 7. We're going to need that for later. Okay. What is our period? Markup. Well, I've already written it down here. Just tell me which one it is. 4. So we're going to go 4 units. I'm just going to call that 1, 2, 3, 4. After 4 units, we should be right back where we started, right? Now, I actually think cosine is even easier to graph than sine because you really only need 3 points. You need your first point, your end point, and then you know right in the middle, you're doing just the opposite. So instead of doing our minimum, right in the middle, we're going to be where? At the maximum. So at 2, I forgot to do the phase shift again. Where are you at, Ryan? Phase shift again. It's all good. It's all good. Once again, nothing's going to change. I'll go ahead and put my max on here. 2, 7. However, once again, forgot to do the phase shift. So, what does the phase shift do? Shifts it right, what, 7/2 units? So, I'm going to take each point and move them personally, manually. 1, 2, 3.5. Take this one. 1, 2, darn it, and a half. And this one. 1, 2, 3.5. And we're no worse for wear. Connect your dots, and you're done. So that was up, and then down. That's not very good, but whatever.
Have you also defined on the same line with the minimum?
Yes. Oh. If it's cosine, it's actually normally your maximum. But because it was a negative, then it's a minimum. Whereas sine, a sine function is a little easier in one regard, in the fact that you don't have to worry about your maxes and mins when you're doing your first and last point. You'll just need to worry about your vertical shift.
So what are the red dots?
The what?
The red dots.
They were before the phase shift. That was our function before we shifted it right 7/2. So let's punch this thing in the calculator and see if we did it right. Don't worry, you're only going to have to graph like 4 today. Everything else you can just give me all the stuff for. Okay. This was the horrible one that Blake thought up in his feeble noodle. -4 cosine 1/2 pi minus, I'm going to have to use fraction for this one, 7 pi over 4, close parentheses, plus 3. Am I missing anything? Touche. Wouldn't make any sense without an x value. Second, insert x. Thank you. Alright, what do I go to next? Window. Let's do our x's first. What is this point right? Oh, I didn't mark it. I apologize for not marking it. That's 3.5 actually. This was 4. But this is right here is 3.5. 3.5. And then we had a period of 4, which means 3.5 plus 4 is what? That's our end point over here. I'm sorry for not correctly labeling my axis. How low did we go? And how high? Ooh, you guys are getting quick at this. I'm hoping it's just a big N. What? What did I do? That doesn't look anything like mine. Did I punch something in wrong? -4 cosine -1/2 pi minus 7 pi over 4. I didn't close my second parentheses. Shabam. That probably changes everything. And there we go. Those parentheses are fickle little guys. Yes. Phase shift goes with the equation -c divided by b. Oh, Yeah, actually, that's the very last thing we did. The red dots were pre-phase shift. Okay. Then all we did was we came down here and said, oh, it's positive, so write 7/2 units. So I'm an idiot for not writing it on here, but I was using 2 units for every one. So I took 1, 2, 3.5, 7/2. Then I took 1, 2, 3.5. I just shifted all my main points right 7/2 units. If you're having a calculator issue with verifying today, I can take a look at it. Like that one, it was all parentheses. That's why I don't even like using calculators, because they can be misleading. You should think, I did it wrong. Yeah. What are you confused about, sir? Oh, that's not a good answer. Well, maybe I'll work with you personally in just a second. Is there a question about the window at all? No? Okay. Here's what we're going to do. I'm going to, yes.
How do you know where we're getting
Oh, okay. Well, because cosine, well, this is flipped over. Normally it's a u, right? But cosine starts on your maximum, right? And right in the middle of them is your minimum. Well, ours is just flipped. So it starts on our minimums, and right in the middle of them is the max. That's what it'll always be. Yep. The blue dots on this one, but yeah. What do you mean the red dots? You know what might be easier? Rather than look at the graph and figure out your window, you could figure out the window. She asked a good question about the window when you punch it in the calculator. The easiest way to figure out your window is before you even graph it. Here would have been the smart thing for me to have taught you, but I didn't do it the smart way. Here's the smart thing. Okay, first off, what was my period? 4. And I've shifted it, what? Up 3? Right there. You should go ahead and put down your Y window is going to be -1 to 7. 4, -4 and 4, shifted up 3. Right off the bat. Next, your X window, okay? You're always going to start at 0. It'll always start at 0 unless you have a phase shift. That phase shift is where you start your X every time. So 7/2 for this one. 7/2, and then for the end point, where it ends, you just take your phase shift and add your period. So that's where you're ending. 7/2 plus 4, 15/2 in this case. Boom, window. That's the smart way to do your window before you ever graph it. Does that make sense? You'll probably have to do one for it to make sense. Other questions? Okay, we're going to change this up just a bit. Rather than give you 40 problems where you list everything, here's what we're going to do instead. Everyone get out a sheet of paper. What's that? Sure. Well, this is your homework. I'm giving you your assignment. I'm going to customize your assignment. You're going to need to write some stuff down. All right. I'm only going to give you like 4 problems. But for those 4 problems, I want you to list all 4 pieces. Amplitude, period, phase shift, vertical shift, and I want you to graph all 4 of them. But it's only 4. Awesome. Well, I can help you with that. Okay, here we go. The ones I want you to do, and the reason I'm telling you it like this, like all formal, is because I'm going to add a vertical shift to all of these. 25, oh, I'm sorry, not 25. Oh, crap, I can't see it. Oh, I'm just assuming it's the same. Here are your problems. 26, and you might want to write next to it, +2 is your vertical shift. 30 with -3 being your vertical shift. Everybody got those first 2? All right, let me flip over to the cosine ones and see what those numbers were. Oh, too far. And let's see, we already did 45. So let's go with 48 with a -1 and 52 with a +4. Anybody need any of those repeated? Together? Yeah, what were the first two I gave you? 26 and 30? And what were the shifts? Crap, what page is it? It is page number... yeah, good job. 533. Page 533. And stop this really long recording.